In this nugget, we're going to describe some tips of working with GNS3 in our lab environment, as well as getting started with trouble ticket number 1. Let's jump in. Now, for this first troubleshooting ticket, I want to take a moment and share with you some tips and insights that are going to make your lab and troubleshooting experience that much better, including how to bring up the GNS3 topology for our trouble ticket number 1. Also, the recommendation that we're going to want to bounce an interface, specifically on DSW1, its logical interface VLAN 10. It's given me some grief, not every time, but occasionally. And to avoid that grief, for every time you bring up a new lab, I would strongly encourage you to go to interface VLAN 10 on DSW1, and that's this interface right here. Do a shut, count to 5, do a no shut, and then continue on with the troubleshooting. Now, here's the gotcha. If you don't do that, it may work most of the time, but the times it doesn't work, you're going to be troubleshooting additional problems due to this interface not playing well with others. So I'm throwing it out there as a variable that you can get rid of by simply doing a shut and a no shut on interface VLAN 10 before we begin our actual troubleshooting. And I also want to talk with you about these devices. Now, these PCs, as well as this server, are brought to us courtesy of the virtual PC simulator that ships as part of GNS3. And by default, I didn't put any IP addresses on these devices. So if we want PC1 to be a DHCP client, all you do is at the console of PC1 type in IP space DHCP, press enter, and that will go through the DORA process, discover, offer, request, acknowledgement. And based on our topology, our DHCP server is R4. So to bring up the lab, we're going to start our virtual machine. This is one that we've installed previously, so we'll click on it and click on the Go button. And that'll take just a few moments to start up. We'll log in with our password of capital NUGGET exclamation mark 23 and press enter. And then we'll double click on the icon for GNS3 right here on the desktop. If you need to resize the windows to make it the way you want to, that's great. I would encourage you to make sure that you can still see the CPU utilization over here on the right. And then we're going to open up trouble ticket number 1. And there are several ways we could do that. You can click on File, click on Open Project, or there's an icon right here for Open Project as well. We can click on that. And then we have 18 trouble tickets that we can open up. So what we're going to do is we're going to open up trouble ticket number 1 by simply double clicking on it. It exposes the files inside of that folder, including a file called Ticket1 GNS3. We'll double click on that file. And that, my friend, will launch trouble ticket number 1 for us. So we can resize this as well. We have these zoom in and zoom out buttons. Also, if you want to see the label information for each of these connections, we can go ahead and click on this label icon right here. And for more training on the basics of GNS3, please check out our GNS3 1.x Fundamentals course at CBT Nuggets. And I would also encourage you to make sure you have the topology from this troubleshooting course, and you can refer to that. I prefer to have that printed out so I can physically see it and refer to it and make notes on it as I work through a troubleshooting scenario. Now, in this topology, I've got 4 routers right here. The frame relay switch is also a router, so is R4, so that's 6. Plus I have 4 switches, that's a total of 10 nodes. Plus I've got 3 virtual PCs courtesy of the virtual PC simulator. So that is 13 devices total. Now let me share with you something. If we turn on all these devices at once, it's going to take a little while for them all to boot up. And CPU utilization should go to 100% while these devices are booting up. However, once they're booted up and we have consoles to each one of them and we have pressed enter so that the system is not waiting for us to press enter, CPU utilization should come way, way down. And because I know that a lot of us are running this on different platforms, maybe some in VMware Workstation, some on Fusion, some on Player, some on ESX, I want to share with you a method that you can use for consistent success. Now, I'm also presuming that you've taken the steps along with me in this course to make sure that 2 devices in GNS3 aren't pegging the CPU at 100%. And the resolution for that we've discussed with the idle PC in a previous nugget in this course. So what I would recommend that you do for starters is I would recommend that you start a few of these devices at a time and then go on to the other devices. And let me give you an example of that. For example, we could go to the ISP BGP web. We could right click it here and simply from the drop down select start. And then R1 as well. We'll right click on R1 and we'll from the drop down select start. Now the little connections on the links have turned green. Also look over here at the CPU. The CPU, at least on one of my processors, is almost pegged, or it was pegged for a little while. Now even though it's come down here, I'd also recommend that you go to each of these devices, right click, click on console, and that's going to bring up a console window to those devices. So there's ISP BGP Web. We'll right click on R1, select console from the drop down, and that put it in multiple tabs in this terminal window. So here I would press enter on each of these just to make sure I have nice and clean console access to each of these devices. And you'll notice my CPU is pretty low. Now if yours isn't at like 0 or 1%, if it's under 10% as a starting point, that's probably okay as well. But what we're trying to do is avoid a situation where we have it pegged at 100% and the topology is not useful as a result. So let's bring a couple more routers in. We'll go to router 2, right click, we'll select start, and we'll go to router 3, right click, and select start. So now router 2 and router 3 are booting up, and we should have additional CPU utilization as a result. We're also going to open up consoles to R2 and R3. So we'll right click, select console, and R3 right click and select console. And in the background, that added them to my terminal emulator. So we'll go to R2, we'll press enter a couple times, make sure it's responding. Go to R3, press enter a couple times, make sure it's responding, and they are, which is great. Let's start the frame relay switch. We'll right click, select start, and then we can open up a console to that as well. Now I'm recommending this as a starting point because virtually anybody on any device is going to have success if their idle PC is already managed, which we've done in a previous nugget. And you may get to the point where you could do this. I'm going to click on stop right up here, which stops all of the devices in this topology. You'll notice that my CPU utilization is extremely low. And I'm going to click the go button right up here, which is going to start every single device. Now, the reason I'm recommending that you don't do that for your very first time is because if your CPU is hurting, and if you are overloaded, or if you're not optimized with idle PC, it is possible that it could take like 5 or 10 minutes for all your devices to come up. And if you'd done them one at a time, it would have been a much quicker process. So if you'll notice over here in my CPU utilization, and so what I'm expecting is I'm expecting those to be pretty darn high until all of these devices in the topology are booted up, and they may stay high until I open up consoles to each one of these devices and press enter a couple of times to make sure that each of the consoles are responsive. So the second piece of this, on a device that can support it, now that they're all running, I'm going to go ahead and click this icon right here, which is going to open up console access to each of the running devices. And what that should do, that should put all of those as separate tabs inside of my terminal emulation program. Now, on some systems, if you click on the console icon and it pops up a couple windows, and there's like 8 on one and 4 on the other, you can simply close one of those or close them both and click on the console icon again. Because I've discovered that sometimes if I launch the consoles too quickly, right after I've booted them up, the system is so busy in starting up those devices that it just doesn't have time to actually sort it out and put all the terminal windows in one window. So if we bring this over, you'll notice that my CPU is pegged. And that's because these devices are waiting for me to press enter at the console. So if we simply go to R1, for example, and press enter, and then I'm going to use the control page down, or we could use the mouse and click over. Now we're at ASW2, I'll press enter. I'll do control page down again, press enter, control page down. And I'm just going to repeat that for each of these devices until I have pressed enter in each of the consoles for each of these running devices. Now I'd like you to notice something. Once I've got a live console to each of the devices and have pressed enter and got a response from those devices, look at my CPU utilization now. It is now back, in my case, under 5%. So on your virtual machine, if your starting point before you launched GNS3 was like 10%-ish, and that's where it was based on your platform you're running it on, maybe it'll go up to 15 or 16 or 20% while all the devices are up and active and consoled in when the devices are running. Okay, so that's my strategy for bringing up the topology, and I would recommend you start with a single device at a time, bring it up, console it, press enter, make sure you have a response, and then bring those devices up in that manner. Now, once you're comfortable that your system can handle bringing up 4 or 5 or 10 at a time, feel free to go ahead and do it. But I wanted to err on the side of caution so that nobody gets left out. Next, we're going to go to DSW1. And on DSW1, we're going to go to interface configuration mode for VLAN 10. And we are going to do a shutdown. We're going to count to 5, 4, 3, 2, 1, 0, and we're going to bring it back up with a no shutdown. And you don't have to do that every time, But I'm telling you, when I built these 18 labs, I had several situations where that VLAN interface, for whatever reason, wasn't cooperating initially. So unless you'd like a little bonus trouble occasionally in your topology, I would recommend at the beginning of every lab, once your systems are all up, I would recommend to bring down this interface and bring it up. Now also, while we're here on DSW1, because this is a router iOS image with a switch port module inside of it, a few of the commands for switching is a little bit different. This is not a showstopper. And let me show you why. If we do a show alias right here on DSW1, here are some aliases that are in the system already for us. We've got an alias called VL and an alias called show VLAN with no spaces. Both of them will issue the command show VLAN-switch brief. The command show VLAN-switch brief is like the command show VLAN brief on a traditional switch. So we're just adding the dash switch part because it's an iOS router with switch port modules. I've also included an alias called showspan, which is going to use the command show spanning tree brief, which gives us the traditional looking output from a show spanning tree. So for example, on this switch, if I did a show VLAN, press enter, it's going to show us the VLANs that exist on this switch, as well as the access ports that are associated with those VLANs. Or if we use the alias showspan, it's going to show us the more traditional looking spanning tree output. So there's VLAN 1, there's VLAN 10, there's VLAN 20, and so forth. And the other item I mentioned is that we'd want to go to PC number 1, and we'd want to do an IP space DHCP, and that will go through the discover, offer, request, and acknowledgement sequence, assuming that everything's working with DHCP and this client. And to get help with this virtual PC simulator, you can just do a question mark, press enter, and it shows the commands available, including important commands such as ping and trace, which are both available here in the virtual PC simulator. So here's our scenario for ticket number 1. The user sitting at PC number 1 has called the help desk and said they cannot reach the internet server, which is this guy right here at 209.65.200.241 by IP address. So it's not name resolution at all. They're simply saying they can't even ping that IP address. And your mission, should you choose to accept it, is to identify where in this network is the fault, or in this topology, multiple faults which could be present, and secondly, how would we fix it? Now we're going to go one step beyond the actual T-Shoot exam at Cisco, because we're not just going to ask you how to fix it, I'm going to ask you to fix it. And you'll know in measurable terms if it works or not, because after you've applied your solution or solutions, you should be able to successfully ping this IP address of the server from PC1. If that happens, you've got success. And with that, my friends, I'm going to turn you loose on your first troubleshooting ticket. Now, for the solution and the walkthrough of this troubleshooting ticket, I have a separate nugget in this course that does the walkthrough and the solution for trouble ticket number 1. And I strongly encourage you to not, repeat, do not look at that nugget. Do not look at that video until you have spent time in this nugget on your own, practicing and working with the troubleshooting. And then, after you've given it your best effort, then you can come and join me for the walkthrough as we identify the devices in the network that are causing the problem, the technology involved with those problems, and what the final solutions are. In this nugget, we've gone through some tips in opening up and working with a GNS3 project. And we've introduced the scenario for trouble ticket number 1. I hope this has been informative for you, and I'd like to thank you for viewing.